But do you see the slides now?
Yes.
Right.
Yes,
okay, very good. No, apologies. Yes.
Yeah. Ignacio, do you want to introduce, or shall I introduce?
Yeah, sure. Well, welcome everybody. Thank you, Harald, for being here. Harald is a distinguished professor of mobile communications at the University of Strathclyde, Glasgow, and the director of the LiFi Research and Development Center. However, he will be soon joining the University of Cambridge as the Eck Professor of Engineering. He also co-founded and is the current Chief Scientific Officer of pureLiFi. And the main reason why he is here is because he's going to be telling us about one of the telecom hubs, the network of networks in the UK, Titan, which he leads. And with that, the room is yours.
Oh, thank you very much, Ignacio, and thank you very much for having me and inviting me to give a talk and to give you a little bit of a colored information about Titan and what we do in this new telecoms hubs on, as you said, networks of networks. So I'm going through a number of slides, but people on the call, if you're interested or have any questions in the meantime, when I go through the slides, please don't hesitate to interrupt me as you think is required. So yeah, Titan is that what we call the platform that driving the ultimate connectivity. And we basically try to have a network in place that allows sort of all elements of a network essentially from the device level up to the protocol level and all these different areas to come together and really create that vision of a connected end-to-end network. In the light of what is sort of emerging in 6G, and I wanted to show a little bit. I mean, there's a paper that's been recently published as part of the ETSI sort of initiative, so pre-standardization. I'm sure many of you have seen that the ETSI technology radar paper, and they've identified a number of technologies that have been seen as important to move forward. And I mean, as expected, artificial intelligence is a key driver for future networks, autonomous networks. And I personally, I'm sort of, my research sits within the optical wireless networks, but there's other technologies, including photonics and terahertz communications. And these are all sort of technologies where I think impact on standardization is expected, or where research is needed, essentially. And I just want to highlight that in Titan, we cover all most of these technologies except the distributed ledgers and future interfaces and high performance computing. All these elements are in some way represented within Titan, and I'll show you in a minute how and by whom, and how we also try to be inclusive and open and create a wider community engagement. So it's really the idea is really breaking the silos of classic research in different networking domains and bring it together. And I've also shown here, and I mean, I'm sure you are also aware of the IMT Vision 2030 document, where now there's an extension. There's in the past there were three different technologies, three different networking paradigms, which is the mobile broadband and the massive machine type communications, as well as the low latency communication sort of elements of a network. This has now been expanded into immersive communications, essentially the metaverse, and also hyper low reliable and low latency communications and massive communications. That really means ubiquitous connectivity across various different applications. And then what's new in the new vision is the integrated sensing and communications. So that's ISAC is coming into networks now, and that basically affects not only the wireless domain, but also, for example, fiber communication networks, and I'll come to that in a minute as well. And then the integrated AI and communications and native AI networks is a driving domain, and you have covered that in multiple talks in your series. And that is a serious direction that has to be taken into account, as well as then ubiquitous connectivity, which is really bringing the unconnected into the connected domain using non-terrestrial networks and also all airborne platforms and all this sort of three-dimensional network design, which is important to cover. And we are trying to really make significant impact in these domains going forward within Titan. So here are the sort of high level objectives that we have in Titan. I mean, one is we really want to bring in the AI and create an intelligent control of all physical layer segments. By that, I mean not only the physical layer segments on the ground, but also in the air and underwater, because we also see increasing interest in underwater networks, not only for monitoring on sort of oceans, but also for defense applications and others, and really bring that into the ultimate network of networks. We would like to identify, as part of the ambition to define new research challenges across the classic research domains, not only within the domain, but really understand how sensing algorithms in the wireless domain can be applied into the fiber domain and so on, and see what are the commonalities and what are the ways that things can be leveraged across multiple domains. And within this, I mean, there's a particular view as well, a particular direction that we want to also find out what's the next big thing in networks. So that's something where we have our eye on as well, blue sky, but also the shorter term sort of contributions to 6G, as we are funded by DCIT, and they have a vested interest in showcasing that contribution. So we would like to as well enable the partner to jointly identify these new challenges and new technologies across the different domains. And I come and will explain this as well. With the three hubs, Cheddar, Husk, and Titan, there's also this new project, Joiner. I mean, you may have heard of it. Joiner is Joint Open Infrastructure for Networks Research. It's led by Professor Simeonotou in Bristol, and that basically brings a experimental platform, a national scale experimental platform in networking to the UK, where again that kind of co-creation should be sort of brought together towards defining and really realizing the first 6G trials in the UK, for example, and others. Titan, as well as the other hubs, are a springboard for early career researchers, and that's very important for them to link into the community, have work together across the UK with colleagues and drive their careers. So I mentioned the 6G objective, that's clearly a very important one, really in contributing to standardization, not only by writing research papers or working with industry, but really actively driving standardization. And we have some resources to be able to do that. In that context as well, then it is something that DCIT is very in. If you look at the wireless strategy that's been published, it's recognized that the UK is world leading in research and research output and research papers, but very falls very short on IPR generation, and that is something we want to address as well in Titan. Encourage colleagues to create this IPR that is relevant for future standards, and hopefully also drive some of the IPR into what's then standard essential patents. And that obviously requires also collaboration with industry. We are currently now trying to formulate and get the right framework agreements in place. And then last point, contribute to standardization, clearly a clearly stated goal. So who are we? I mean, here are the partners geographically sort of shown. These are the current partners. As I said, we want to be inclusive and have calls for inviting wider participation. So we are 16 universities, and you see these red dots. These are the universities geographically spread with different expertise in different areas. But we also have the Compound Semiconductor Center in Wales, and we have the Digital Catapult, the Bristol Digital Futures Institutes for socio-technical aspects of the work we do, as well as the Fraunhofer Cup, really looking at devices and also helping on the translational research. As in terms of co-investigators, I can share the slides later on, but you see we have more than 40 co-investigators currently in Titan, and as again we have representatives from the different institutes that are partners as well in Titan. So the way we've structured Titan is essentially into 6 what we call lighthouse projects, which reflect the different network elements. And the first lighthouse project is on network intelligence and the end-to-end integration. It's led by Professor Simeonitou in Bristol. And that is you see a little slightly thicker sort of line in the box. That means it's a central lighthouse because it affects all other network elements, and we really want to bring that together into native AI within networks. I'll show what we mean by this in a minute. We have a second lighthouse project which looks at user-centric and service-aware radio access technologies. That's led by Professor Matteo in Queen's in Belfast. A third lighthouse project is on optical wireless networks, where I think the UK has a very good and leading position already. I spun out pureLiFi, and pureLiFi was the driver for a new IEEE standard 802.11bb, which is essentially an optical wireless networking standard, and we want to build on that and essentially make a similar impact on 6G. We have fiber connectivity, and that's with Professor Petropoulos in Southampton. And then very important area of our sort of focus is non-terrestrial networks and optimization and tackling the various problems that arise when you go up into LEO, MEO, and GEO satellites in terms of latency, in terms of delays, in terms of Doppler. Fundamentally understanding what are the limits, and then bring those segments into the network. And the question is how to orchestrate a satellite link alongside a sort of a short-range Bluetooth link in an intelligent way in order to ensure sort of best end-to-end connectivity. So these are some questions we're looking here. And last but not least, it's very important, I guess, for us to build a bridge into the quantum clusters, into quantum hubs, and that's why we have quantum network integration as a lighthouse project as well. It's my colleague Professor Penty is leading that activity, and that really goes beyond the classic QKD sort of key exchange. It's looking further down into entanglement and bringing other aspects into the networks as well. So overall, I mean, the overall KPIs, I mean, they are no surprises, but really we're looking at terabit per second capacity, gigabit per second per square meter density, microsecond latency, and really also the energy efficiency in bringing that down as well as pervasive coverage and equal access to services across the globe. And that is sort of incorporated via these cross-cutting challenges. And that is really the important thing that makes it more than just 6 different projects. It is that yellow bar that connects the things up and tries to leverage knowledge developed in one lighthouse project to be then used in another one, and also trying to do some end-to-end optimization. And one classic problem is, for example, the energy efficiency. And in the past, the energy efficiency has always been looked at in various segments of networks. And I know it from wireless, and there's been initiatives in the past with green radio and so on. But it was a very limited view of one particular networking technology. But the real question is, what's the end-to-end energy efficiency? What is the impact of AI machine learning in networks and energy efficiency? How can that be reduced while benefiting from the advantages of intelligence towards sort of the self-X networks? And those questions are all being addressed in this cross-cutting challenges. And that's why all researchers will come together regularly and exchange their research and their ideas, and really we are driving it jointly together, tackling these challenges. And above the challenges of the cross-cutting themes, and that that is all what people call it KVI, key value indicators, but in 6G hexa-X, for example. But these are the driving motives towards it. So we've broken it down from top down to bottom, and we have little in Titan at the moment. We have 33 what we call mini projects that are basically attached to these lighthouse projects we can call it leaves attached to these branches, and that forms sort of cluster of activities or beacons of activities within these networks. So maybe if I drill a little bit further down into the technologies and the research challenges across the different lighthouse projects, I mean, we'll see that on that slide. On the network intelligence, one important area we're working on at the moment is also part of a future FONRC funded project, is multi-intelligent controllers. So the idea here is to really have an air interface agnostic network. So you can plug in any type of air interface into a network, and the network makes use of that air interface in an agnostic way. And that requires a lot of coordination, intelligence, and also additional protocol signaling and so on. And that's an area where we focus on network intelligence. On Lighthouse project, we focus very much on cell-free, high-density wireless networks. On the energy efficiencies is one, as I mentioned earlier. Things like massive and holographic MIMO are technologies that are emerging and we want to bring in, as well as RISs, reflective intelligent surfaces, as well as sub-terahertz communication. So this is the cluster of activity in that Lighthouse project. In the optical wireless communications, so we really look at towards net zero data links, and also very high performing long range links for satellite communications, for inter-satellite links. Starlink uses optical wireless communications modem at the moment to connect satellites. So we would like to build on that and give it a particular UK stamp as well in that technology domain. Terabit per second is something we target in this lighthouse, as well as satellite underwater networks, as well as the integration of LiDAR with communications. And the devices that you use, for example, for LiDAR application, it's vertical cavity surface emitting lasers. They are very powerful devices for communications as well. And we basically utilize those devices for these dual purposes. On the net zero data links, we are utilizing solar panels for high-speed gigabit per second antennas in optical wireless. So we have essentially two functions within one device. That's why we can drive both data rate and harness sort of free-flying photons in the air. That's some work we do in Lighthouse 3. And Lighthouse 4 is on the fiber networks. Holocore fibers are, I mean, a UK-born technology that we want to bring into wider use in networks for low latency, but also for power transfer through fiber, which is an important topic. And you see spectrum management, for example, one key topic, and also the integration of sensing for networking in fiber networks is of great interest. In non-terrestrial networks, we look at the optimum resource allocation for multi-component optimization, integration of aerial platforms, reliable high-speed data links from ground to satellite, and so on. And then in Lighthouse 6 and quantum networks is new architectural solutions combining classical and quantum networks, bringing end-to-end physical layer security, building sort of enclaves of security, and developing QKT further by bringing in entanglement, for example, into that equation. And all of these things develop bespoke sort of network segment specific technologies that then they are all brought down into the open, into the joiner platform, so that we create this sort of end-to-end experimentation within that platform. And that's essentially the experimental glue that brings all the technologies together towards that end-to-end vision. And that's what we want to do together with Joiner. So I mean, a little bit, I mean, on the structure is as I said earlier, we are operating on that principle of having these lighthouse projects, but then we have these leaves around them, which are the mini projects. And the mini projects drive the objectives O1 to ON within the lighthouse projects, but they also drive the cross-cutting themes across the different lighthouse projects. And the real innovation, the real key in bringing things together is really the blue links, the mini projects that span across the various lighthouses, and that's what we want to drive and continue to do so. So I should also perhaps spend a few words on the Titan governance and the way we have organized the federated hubs. So we have these hubs as a standalone hub, with its management boards and so on. And then we have the joiner. It's the four entities that form that federated hubs structure with a federated hubs governance board. But most importantly, or very importantly, is we have a governance function that we coordinate via Titan, which has essentially four functions. One is what we have in Titan is a CTO, which is essentially what Chief Technology Officer does, looking at technologies, doing sort of technology scanning, technology horizon building, and also linking into the engagement with industry, looking into engagement internationally, building international alliances. And there's a lot of work that on the out-facing work CTO will be doing. Then we have a standardization director that really looks at driving the research in these different lighthouses into various standardization bodies, 3GPP, for example, and others, IEEE. And alongside the standardization director, there will be four researchers whose role is very simple, is to work across the entire platform, so all the three hubs, and examine sort of what are the key technologies where there sits an IP behind, an IPR behind, that could be brought into a standard, and really scanning that and bringing technologies then into standardization meetings, and likewise attending standardization meetings and looking what are the trends and where things are going, and feeding that back into the research groups in order then to shape the research in a certain direction and also help create new IPR, because that is one important direction we want to take. And the third function is a skills and training director. We have noticed and recognized that in wireless in networking there hasn't been really sufficient CDD support. And there's a big gap in skills that we require, and it's really hard to recruit from outside. That's why we need to build and provide some upskilling opportunities and also going out into schools and doing some outreach. And then obviously we need somebody who tries to have a marketing interface and really help bring that entire activity together and be an interface to the outside world. So this is roughly how the overall structure works, and the project is very short term until sort of March 25. The TMF funding element of the hubs, and that's recognized. And in order to make impact on standardization, we need a longer sort of engagement. And the hope is that we'll be able to continue that activity beyond the initial sort of seed phase of the hubs. So a few words then on the different lighthouses, and this is sort of slides that have been provided by the respective lighthouse leads in collaboration with their partners. And here with Lighthouse Project 1, I'll just show you a little bit the thinking in the plans within this lighthouse. And this is a slide that Dimitra sort of shared with me, and she sort of highlighted the current state of the art of networks, where the main problem is that AI and ML is sort of attached, bolted on to current architectures in networks. And the question is, can we move away, and should we move away from that structure and build native AI? So AI embedded into the network design. So creating the end-to-end intelligence, because networks become increasingly complex, because we need real-time data decision-making. If we go into really an intelligent network, the self-access I've mentioned earlier require quite a massive improvement in decision-making, predictive proactive maintenance, personalized service delivery, energy efficiency, sustainability. These are all topics that require really intelligence and security embedded into all layers and all functions within a network. And these different AIs need to be orchestrated. And the question is how to orchestrate them. And this is how we plan to do that, or people colleagues in Lighthouse Project 1 want to do that. As an example, is building this controller here, the Matrix multi-access technology real-time intelligent controller, where the idea is that we have different air interfaces that you see here, air interface 1 to N, that are orchestrated within that function in a way that you can plug in any air interface, and then you provide that functionality into the network. And then we have the X hubs within that layer, as well as the X hubs around energy efficiency, and then have domain service orchestration above it. And then alongside all of this, there's two real important functions. It's the end-to-end monitoring that really builds the database, and the native intelligence that is brought in via the cognition and the artificial intelligence interfaces into the network. Details of that, again, all driven by Dimitra, and I'm showcasing here only sort of the rough directions where people in the Lighthouse Project want to drive that research. A few words about Joiner here as well, and Joiner is, as I said, the experimental platform underlying all of this. And it's a national scale experimentation platform. It connects 11 different institutions at the moment for that joint experimentations. And one of the key objectives is really running the first 6G trials on that platform with all the technologies, or some of the technologies developed in the various lighthouses and in other hubs as well. It supports the wider telecoms ecosystem, so SMEs and industry as well. So here's sort of the current structure of the joiner platform with the different sites that you see here, and the backbone of it is the National Dark Fiber infrastructure. It's led by Professor Alvin Seitz in UCL, and within that as a backhaul, we have then the various institutions which will have a joiner terminal that would provide multiple access technologies, but also provide the computational platform, including cloud services for this joint experimentation and development of new techniques. The joiner platform has three principal elements. One is the joiner brain, where the control and measurements and the orchestrations will happen. It is the joiner terminal, which has all the services from layer one, different technologies, up to computational platforms, and a joiner fabric that really brings things together towards that CPE node and the network element, within which all the different lighthouse projects can be served, and everybody can implement somewhere on that complete infrastructure across these three different principal elements of joiner. Lighthouse Project 2 is again on the radio, a new advanced radio network integration. Professor Michalis Matteo is leading that in Belfast. So there we are looking more on into the physical layer of things, such as I said earlier, cell-free massive MIMO, wireless power transfer and communications, integrated sensing and communications, terahertz and sub-terahertz and RISs, as well as the integration of aerial platforms. So a lot of new technologies will come out of this work package that are again linked into the joiner platform. One initial work that group has achieved is for example on a circular RIS structure, implementing new different users, but there's a particular benefit of using sort of these circular structures of an RIS. That's one direction. Another is sort of communications and sensing, and the idea is really having base stations that operate in the near field to different users, but also have far field targets where they measure and monitor targets in the far field. And then you have different carriers that are intelligently managed to allow both functions, communications and communications. Optical wireless network integration. So that really brings the networks into different other dimensions. For example, underwater, ship to shore, and then shore to hubs, high altitude platforms, inter-satellite communications, and also the communications between drones, and communications also within homes, where we have very dense wireless networks towards terabit per second capacity per room. Something we do in a program grant which is led by KCL. It's called TAUS. And then again, pervasive communications with again solar cells here, for example, as data receivers, and then you have them operating as RISs potentially as well, serving different use in different locations, so that really bridging the gaps that exist at the moment. On the fiber integration, very briefly, again, the idea is looking at intelligent ultra wideband systems. At the moment, fiber sits primarily in the C-band, but there's certain advantages of using the O-band because the dispersion is low for optical, for analog sensing and control, and also for power transfer. So really expanding the capability of fiber networks by looking at broader spectrum is one of the targets and the topics of interest in Lighthouse 4, as well as multi-core fiber. So really allowing different fibers to run in parallel. That requires more intelligent switching techniques because it's becoming a more complex problem. There's also the idea that we use all optical communications with combining fiber comms with optical wireless, where there is no translation from optical to electrical, and then electrical to optical. We switch out that electro-optical conversion and have full optical networks, which has a great benefit for future quantum networks, but also allows very simplified networks by really merging fiber with wireless in the optical domain. Other areas I mentioned, hollow core fibers, and then all optical networks touched upon that. And then because of the nature of a fiber medium, which is highly nonlinear, the question is there new physical layer techniques, new signal processing techniques on nonlinear Fourier transform that would make those communication systems more efficient. That's an area of interest. In Lighthouse 5 on the non-terrestrial networks, it's all about the integration of drones, satellites, but also sea. I mean, bringing coverage, sort of cellular coverage to ships is one of the unsolved problems. And the idea is to build the networks and the resource allocation mechanisms to allow these networks to function. And that often comes with multi-objective optimization problems, where you want to optimize across the bandwidth, being efficient because spectrum is limited, power, optimize on energy efficiency, quality of service, and across the various techniques that I've mentioned earlier. And then that really forms a very complex optimization problems. And the idea there is to, again, use machine learning to solve these multi-objective optimizations. And that's, again, led by Professor Hanso in Southampton, which also has recognized the high Doppler. You see a Doppler profile of a channel with a satellite link. And the high Doppler had a high variation, and the shift in frequencies is a challenge that has to be overcome. And with non-conventional techniques, as this is not, these kind of Doppler shifts don't exist in a terrestrial network. And here's an example of a optimum resource allocation, where you have, what they have done is connecting two places here, and in Europe and America, you could have a LEO satellite, so have a link via a satellite here in red, or you could have a path, a communication link, by using airplanes that basically fly on the north and on the east-west route, and have multi-hop networks there that route data traffic through that chain. Quite clearly, a minimum path, a minimum delay path, and there's a maximum capacity path that they found, that you see with the dotted lines, that go through various platforms on that link, and then there's a maximum lifetime path. And the question is where is the Pareto optimum front for these different optimizations? So you could have a very low delay path. That means you cannot have many hops, but the lifetime is very short because of the nature of a small hop. Or you can go for a long delay, and that is with a long lifetime because it's via a satellite. So the question really is, what is optimal for the particular application? And then you find intelligent mechanisms to route traffic either via a multi-hop direction or via satellite. And then on the quantum networks, there is really the vision here is to build trusted enclaves in networks at the edges or a different location at switches where QKD and beyond QKD entanglement-based QKTs can be used, and then really driving that security mechanism forward into networks is one of the intention here. So I'd like to summarize then that the Titan project is bringing it together again as a collaborative research effort to define the future network of networks. It's inclusive, so look out for a call for mini projects at this link here. It's at the moment it's an empty link. Don't go to it. It's nothing on it at the moment. But next week we want to equip that with a call for participation across all the hubs. So we have in total £4 million that we want to use to engage the community. We are very much looking into translation of research via IPR standards and spin-outs, skills, technology road mapping, looking at beyond 10 years, identifying the next big thing that the UK can be leading in this domain, and really driving international partnerships and alliances is a declared objective. So I've run through very quickly. I noticed and rushed through in a sense a little bit, but I hope nonetheless you got an overview of what we do, and happy to take any questions.
Thanks so much, Harald. This is really really a whistle stop tour of huge number of topics there. I noticed that there's a few comments / questions in the chat. I can read them out, or John, if you'd like to speak to it. I can read out the first. Yeah, go ahead, John.
Yeah, okay. So actually, the one thing I was interested in, you have a lot of partners. You're also missing some major comms people, but I guess this call will allow you to fill that gap, which is fine. But one thing I suggest is you get in touch with the Connect IE people in Ireland, because all the Irish universities for the last nearly 10 years have had a single project funded by Science Foundation Ireland, which is an extremely similar list of topics. And they have some really good people, and they also have a politically neutral way of working with at least Queen's Belfast directly. So there are common projects across there, and there'd be no problem with doing that. But it will get you, it doesn't have to be EU. It's just, which is not a problem either, but it wouldn't look like a giant thing. It would just get you a whole bunch of extra expertise links, immediately in all the areas, rather nicely, particularly people at, Trinity Dublin, for example. There's some really great people in these areas.
That's hugely helpful, John, and that is really feeding into our objective in creating international links, and that seems to be a very, very sort of obvious natural international link we have to establish. Thanks for that link. Thank you.
Okay, cool. That's the other question was really about there's a number of us who work in internet standards where actually IPR is a barrier. It's actually not the thing. That doesn't mean you can't exploit things. In fact, Mark Handley is right now making a shed load of money building switches based on work that he did, previously as part of research projects funded by UKRI and so on. It's just you have to kind of make a slightly different approach, I think, than the kind of device people and transmission people are used to, where obviously if you build the kind of thing Richard Penty does, you have to patent the devices. I get that, but it's kind of more software layers. The approach is slightly subtly different. So, but it doesn't stop you having an exploitation path. But it might be worth asking people if they're looking to join in and they have a kind of internet standards approach or World Wide Web, consort W3C, if they are aware of how you do that, because I think some of the people in online here do know how to do that. I know people, like I say, Mark Handley at UCL, for example, has successfully done, and I have colleagues in Cambridge in computer science. So might be good to just say that doesn't, that's not a barrier. It's just a different style. Maybe that's just a comment, really.
I'm fully aware, and I was nervous when I talked about IPR into this community, because I know you see this more as the devil that to avoid. But I mean, there's others in DCIT that are very, very well aware and really want us to drive IPR, and they're funding us, so we really want to respond to that. And I mean, I've seen it with my own company, pureLiFi. It works if you spin out a company and you want to get investors on board. I mean, the first question is, what is your IPR? I mean, we really want to drive the SMEs. We want to drive the ecosystem, but respond to both sort of paradigms. And absolutely, would like to learn actually more from you on the way you approach in things, John. There.
Okay, thanks.
Thank you.
So does this mean that SMEs will are able to work directly with you, and are part of funding is for giving it to them, or is that somehow different from the usually PSRC?
It is the PSRC rules, so we can't fund the industry. So, but doesn't mean that we want industry partners to work with us, and we believe with that platform joiner and the hardware that's being installed at these places I've shown, and the opportunities are created. I think people can link into that, and we do hope that SMEs come in, and we need to build the framework agreements, obviously, to allow them to do that. Again, questions around IPR will arise, but that's the things we want to develop, and really want to take communications research, because communication networks really are pervasive and everywhere. I mean, and yet it's in research, it's sort of broken down into these different silos, different communities, and I strongly believe there's great value to break these silos and come together and share approaches, share methodologies, and share also visions, and I mean, that's why, I mean, what John just said is really valuable, because we want to bring things together in some sense.
So, and in terms of how the NGN community or anyone else can engage with these, we previously had on here, and it looks like there are some small federated projects that are being planned. But from what you're saying now, this federated telecoms hubs is that a single site for across all of these different hubs, or how do?
So the idea about the federated hubs is sort of a virtual governance, that we want to operate these hubs not in isolation, but in collaboration, and make sure that we leverage mutual developments across the hubs. Again, not falling into the trap and having, again, higher granular silos built. And that's why we have this structure in place. And the call that you will be seeing is across the 3 hubs. And then the people can decide where they want to put in their proposal, to which hub they want to link it. But again, yeah, it's a loose governance.
And I couldn't quite tell. This will be my last question, I promise. I couldn't quite tell what how joiner fits in. Is that supposed to be a 4th hub? Because initially, I think I thought the call was for 3 hubs, or is it going to be cross-cutting across all the 3 hubs that you have, apart from the federated governance structure as well?
So joiner is a separate project that supports the hubs in building an experimental platform. It's really building the experimental platform. The research actually happens in the hubs. So the research will be built in the hubs, and that the outcomes of these research results will then be hopefully translated into the experimental platform. Because in many cases, for example, I know from wireless communications, algorithms are tested in MATLAB, but then they live in MATLAB and end in MATLAB. And whoever has done some practical implementation realizes, okay, there's a few assumptions that maybe not that realistic, and you have to think a bit deeper if we want to implement it in real time. The hope is really that these algorithmic works are making it into that platform and really tested in real life, that we have RIS is tested alongside new air interfaces, as well as new AI machine learning network elements to really bring out the end-to-end service, and also looking at energy efficiency, which is another big topic given what communication networks consume at the moment, and if you bring it forward, what they will consume if nothing is done in order to make it more energy efficient. So yeah, I mean, it's hopefully trying to create that collaboration.
Yeah, it's a comprehensive ecosystem. Well, I would like to open the floor for other questions, if there are any from anyone.
Maybe then one for me, following up from the one of John. Which standardization bodies are you planning to engage with, and how?
Sorry, Ignacio.
No, I was asking, following up from the question of John about the standards, which standardization bodies are you working with, and how do you plan to work with? I presume ETSI, 3GPP.
Yeah, I think you're basically we are at the moment having sort of ETSI in the frame, as well as IEEE and 3GPP. So these are these are the things where I know DCID also wants to have some impact. So that's where we probably start with. But IETF and others are certainly as well on the agenda and want to be broad, but we need to be also mindful in terms of the time and resources.
And what does UKRI expect to be delivered by Titan, and how do they plan to measure or check, what is the success of the project?
I mean, it's fun. It's an EPSRC project, so the
Yeah.
EPSRC handle that, and we've laid out the objectives. I mean, they are in all our hubs, and we want to achieve our objectives as a research project. But we'll also like to do some additional work, and I'm aware that DCID is looking at that translational element, really creating impact on standards is one objective, and we want to help the UK doing that. And in a sense, I mean, there is the you have seen the diversification strategy. There's geopolitical shifts around technologies, supply chain, and standards. The open question: will there be a global standard, or will it be fragmented? Hopefully not fragmented. So there's a number of wider political sort of considerations. And I mean, in the past, if you look at past generation research on 4G, 5G, it was fairly sort of concentrated, shall I say? But now what we really want to do is democratize, in a sense, the research in 6G and allow everybody, allow the full strength of research capability to the UK to participate and link into defining and making UK contributions to standards, and that's what we want to do with the hubs, and that's been recognized. And for example, we had a community call 2 years ago to define or provide input into ITUR, into IMT Vision 2030. And there was a paper that was presented, which had a lot of groups' input around the metaverse and around sort of the immersive cyber-physical continuum. And that paper was recognized in ITUR, and some elements of that are now recognized within that vision document. So really we want to take everybody along on board and help building a stronger UK presence in the world, and obviously building on the available strength. And we recognize that we have not at the moment everybody on board we should have on board, and that's why we have this calls, and there's £4 million across the hubs that we want to help engage those that have to be part but are not yet part.
And that
Great.
brings
Thank
us
you. That's very
very
interesting.
nicely onto the exactly 5 p.m. So
Yeah.
unless there are any urgent last-minute question, I guess we thank Harald in the usual way. Thank you so much for coming and giving us this tour of what Titan is about, and we look forward to the calls on Federated Telecoms Hubs and other ways to engage with you.
Thank you so much, and again, thank you for inviting me.
Thanks a lot.
Thank you very much.
Have a good weekend.
Bye.
Bye-bye.
Bye.